Today in lab, we're going to do a series of acid-base reactions and test the pH of them. Previously, we may have tested pH by colorimetric titration. Now we're going to actually use a pH meter. So today, we're going to need a whole ton of graduated cylinders, some beakers, a whole bunch of solutions such as acetic acid and ammonium chloride, sodium acetate, ammonium hydroxide, sodium hydroxide, HCl, tap water, and what have you. So, and the most important thing is the pH probe. So we're going to have our lab request, a pH probe, and our calibration solution. Now, I'm going to try to calibrate this one time and use this for 3 separate labs. Some may call me mad. I just call myself ambitious. Let's begin. The pH probe is a glorified conductivity sensor. Each ion conducts electricity a little bit differently, and the pH probe has been calibrated to just detect the conduction from hydronium atoms, the hydrogen, the proton. Now, what we're going to do is to calibrate this in 2 different concentrations of protons, and we're going to be able to draw a linear curve through those lines to be able to detect various other numbers. So we're going to censor. Right now, it's currently in the storage solution, so it doesn't dry out. So I got to put in the first number. As I pull this out, one thing. Oh, geez. One thing to keep in mind is that between each, you should be washing this off, washing off the probe, and then patting it dry. We don't want to be introducing any more moisture than already is there, thus diluting our solutions. So we'll start with pH 4.0 solution. Stir it around, get it all nice and you can tell it's pH 4 because it's pink. Five, 4, 3, 2, 1. Give enough time to calibrate. Put in the number 4. Put that aside. Wash this off again. Pat this dry. So the probe is not going to be introducing any error, so we're not putting any high acid concentration into the low acid concentration, thus throwing our numbers off. This is our pH 10 solution. So concentration has changed by a factor of 10 to the 6th power to go from pH 4 to pH 10. We got firmly acidic and firmly basic region. 5, 4, 3, 2, 1. Now, it should be pH 10 to more or less extent. We're going to use this one for all our tests moving forward. In this part, we're going to be testing the same thing multiple times. We're going to be testing the pH of a solution. We're going to be doubling its volume, thus halving its concentration, and be testing the pH again. Then we'll be adding a small amount of strong acid to see how it will cause the pH. Our first solution is 0.01 molar HCl in approximately 20 mils. Now I'm getting my pH probe, squirting it off, drying it off. Chem wipes. Turn it around. What is the pH that I read? I let this settle down. So right now the pH is dropping a little bit. It's got to reach bottom out. It'll slow down until it gets to a point where it doesn't really change by much. Okay, probably good enough. Now I'm going to take this out, add another 20 mils, put it up to 40 mils, stir this. We want to be uniformly mixed. Put the pH probe in again. And as you'll see in a second, pH has gone up, not down. The amount of water in there, the amount of hydronium concentration has gone down. Finally, last step, I'm going to add one more drop of acid. Just a drop and then stir. And I know, riveting television. For the sake of time and sanity, I'm going to speed up the next couple processes. So this next one, well, really, they don't have to be done in any particular order. The next one I'm going to do is sodium hydroxide. So 0.01 molar sodium hydroxide. This is a base. As I'm doing this, predict, where do you think the pH should be? once I measure this. Predict how these changes should. Now we'll attempt sodium chloride. Acetic acid. Ammonium hydroxide, a weak base, also known as ammonia. Tap water from the sink. Deionized water. In this part, we will first add the conjugate acid to a weak base, or the conjugate base to a weak acid, measure the pH, add the appropriate base or acid to make a buffer, measure the pH, dilute it, measure the pH, and then finally add a few drops of acid to see how that might affect the pH. Do that with both, then we'll be ready for calculations. So here's our ammonium chloride. we're going to add our ammonium hydroxide. Double the concentration. And a squirt of acid. Here we have our sodium acetate. I'm going to add in my acetic acid. Forgot to show the addition of water, but here's the pH. And a little bit of HCl. Finally, we are ready to do our calculations. You have all the pH measurements you need to calculate concentration of H plus, OH minus, pH, and pOH for every situation.